Let's talk for a minute about Autodesk and its capability of preparing models for CAE analysis. One of the main things we have to be concerned with quite a bit is how our designs are going to function and how they're going to go out into manufacturing. Autodesk has built a lot of this technology into Autodesk Inventor, but sometimes we want to get a little more information, or we want to do a type of analysis that doesn't exist inside of Autodesk Inventor. So one of the things that we need to do is we need to prepare those models so that they can be fed out to a structural package or a filling simulation package, some type of an analytical package that I can now continue my digital prototyping. So how do we do this? How do we prepare these models? And what if these models come from an outside source? And that's really the concern that a lot of our customers have. If these files come from a source that is outside of the Autodesk Inventor suite of products, do we have a way of preparing these models for CAE analysis? So what's the point in getting a model ready for this type of an analytical simulation? Well, the idea behind this is that we want to make sure that the models accurately represent the geometry that we're trying to simulate in the situation that they're being simulated. And we want to make sure that these simulations are accurate, but we also want to make sure that they run quickly so that we can get fast answers and make decisions without holding things up, holding up a design process. We also want to make sure that we have very few problems with that mesh. And that can be addressed quite a bit by the detail and the level of information that we put into these models that we start with. For example, quite often in injection molding, we'll have tooling rounds and we'll have small features that may not be critical to that simulation that we may be able to remove off the part. That'll create faster run times, faster meshing times, fewer meshing problems, and give us just as accurate a representation of this model. So let's take a look, for example, at some numerical values of this from another Autodesk program, Autodesk Moldful Insight. If we take a look at these models as they're created in their natural form with all of the detail in there, you can see that we create more elements, it takes longer to mesh, we have more issues with this file, and it's going to require more time to clean up just because of the level of detail. By simply taking something as small as the text off of the part, we can make a significant impact, a 10% impact, in the number of elements that represent that geometry. This now means that I have less elements to clean up, I still have an accurate representation of my model, and I can run my simulations much faster. The same thing holds true if I start to take off some of those tooling rounds. Again, now I've got a 25% decrease in my overall mesh count. I've got just as accurate a representation of my file, and I have created a more accurate model that I can now simulate inside of these packages. So let's take a look at that very thing. Let's take a look at the Autodesk Moldful Insight line of products and see what exactly we're talking about here when we say these things. If we take a look at Autodesk Moldful Insight, you can actually see here the three different models. Over here on the right side, we have the most complex of these models. And if I turn this over, you can actually see the text on the bottom side of this file. And if I go back down to the top side of this, of course, we can go back in and we can zoom in on the center section here. We can actually see the level of detail in the rounded features. This is information that we really don't necessarily need for these files, because as we take a look at things, say like our temperature plots, you notice that there is no significant change in the temperature simply by representing this information. The same thing holds true if I take a look at, say, even an XY plot of my pressures. You notice that my pressures are practically identical between these three models. So by simplifying the model, I've created a more accurate representation of some of the thicknesses. I don't have to calculate the complexity of those rounded features. I don't have to worry about the complexity of the text because it's not playing a major impact, and I'm still maintaining the accuracy of my file. But how do I do this in Autodesk Inventor, especially if this file was not created native in the Autodesk Inventor software? And that's one of the things I want to talk about today, is not only do we have the ability to modify these files with Autodesk Inventor, especially if they're created inside of the Inventor software where we can modify the design tree, but we can also take the base solid or the dumb solid files and we can start to make modifications to these as well. So if we take a look at this file here, you'll notice that it has a series of small rounds on the inside of the part, and it also has text on the back side. Now we're going to address each one of these one at a time. So how do I do this? Inside of Inventor, all I need to do is take my solid file, double-click on it, and I can now come into the specific features that I want to deal with on this. For example, if I no longer wanted these rounds on my part, I could simply highlight it like I've done here, and then tell it to delete this geometric feature off of my part. I can do the same thing by specifying multiples. So if I want to select all these features at one time, I can select them all at once and do the same thing. And the same thing holds true for any other of these features that exist on this geometry. Say these internal features here. I could just as easily move around on these and select these features. And delete these away as well. So again, a very fast and easy way of representing these, a very fast and easy way of making modifications to these, and a very quick way of cleaning up my models. Now at the same time, if I take a look at my geometry, I still have that text on the back side of my part. So let's take a look at that text. Let's see if there isn't something we can do with this now too, in order to make a cleaner looking file that we can now represent inside of the software. You notice that the text mess is sticking up here, and as we saw in the simulation, it wasn't playing a major impact on our results, but it is creating more and more issues for us. So let's take a look at this, and let's expand and contract this information. So if I take, say, this surface here, and I want to now contract this down into the surface of my part, I could simply measure the distance that the text extends off of that surface and move it down in and make it all flush so that when we go to create this information, we can now contract this down in one big step and make a flat surface. So very quickly we can clean these files up, remove a whole bunch of small detail that is not going to be critical to my CAE analyses, and create very quick, very smooth, accurate models that are now capable of being meshed much faster and run on my simulations much quicker.